Assalamu alaikum children. How are y'all? Can y'all hear me? Am I audible to y'all?
Walaikum salam, miss.
Okay. So we'll start. Right. So this is a free session. Inform your friends about the class that is happening right now. So then they also will be benefited out of this. Right? Okay. So we'll start. So today we will be starting an important lesson of grade 11, right? So normally when you talk about this lesson, which is electromagnetism and electromagnetic induction, right? Today we are going to start the lesson electromagnetism and electromagnetic induction. Right. So now when you talk about this lesson, first of all, let me tell you the importance of this lesson. Right. Let me tell the importance of this lesson. Give me a minute, children. Right. So today, let me tell you, we are starting this lesson, and this is not a easy lesson, right? To be honest, I just don't want to lie to you all, telling that this is easy and within a day you can study. No, it is not possible. This is a long lesson, and this is not theoretical. There is no such where you can memorize stuffs and write. That is not present in here. What do you have to do? You have to practice. Instead of memorizing, you have to practice questions, right? So therefore, children, we will be taking around 3 to 4 weeks to cover this lesson. 3 or 4 weeks to cover this lesson, because this is very important, because this lesson you can get in your essay question. Right? When you take your O-level paper, analyze this, you can get it in the essay. But you will not probably get it in your structure. Right? That is actually one advantage. That is actually one advantage from this lesson. Right? So now we'll start. We'll start to study. We'll go very step by step with a smooth flow. You don't have to be in a hurry to learn anything. We'll go with the flow. Right? Now, when you talk about, first of all, we are going to talk about electromagnetism. Then later we will be talking about the electromagnetic induction. Right? Now when you talk about electromagnetism, right, you're going to talk about electromagnetism. Right? So this is a magnet. You are going to talk about magnet. Right? Now when you take magnets, right, when you take magnets, there can be two types of magnets. There can be how many types of magnets, children? How many types?
Two types
of magnets.
Two types. You all have to talk to me. That is where you will study, right? As I have told you earlier, you have to talk, you have to interact. That is where you are going to learn, right? So when you talk about the types of magnet, one is electromagnet. One is the electromagnet, and the other one you call it as the permanent magnet. And the other one you call it as what? Permanent magnet. Right? So now let me tell you the difference. Let me tell you the difference between electromagnet and permanent magnet. Electromagnet means, now you know what is magnetism? Magnets has magnetism, right? The force that magnet has. What is a magnet? First of all, the ability to attract an object, that you call it as a magnet. That is the work of the magnet. So the attraction of another object, okay, the attraction of another object, you call it as the magnetism. Okay, you call it as the magnetism. So magnets have magnetism. Magnets have magnetism. Electromagnet means where the magnetism is shown. right? Electromagnet means where the magnetism is shown when there is a electric charge or a current passing. Okay, when the current is passing through the magnet will observe, right? That type of magnet you call it as electromagnet. Let me tell it once again. You have two types of magnets, electromagnet and permanent magnet. What is meant by electromagnet? In electromagnet shows the property of magnetism when there is a current pass through it. That you call it as the electromagnet. What is electromagnet? Now it's a study and finish it off, children. Please don't keep it for tomorrow to study. That doesn't work all the time. So now it's a study and finish it off, right? So what is electromagnet? In electromagnet, the property of magnetism is shown when there is a current pass through it. That type of magnet you call it as electromagnet, right? Permanent magnet means where they don't need current. They will all the time have the magnetism, right? All the time they will have magnetism. They don't need current, right? So electromagnet means one factor that is needed is the current. Here there is nothing like that. Throughout the thing, whatever, even the current is there or not, the permanent magnet will show the property of magnetism. So magnets like bar magnet, the bar magnet or the U magnet, so those are permanent magnets. Those are permanent magnets. So electromagnet we will study further. We will study in a while, right? Okay. Now, when you talk about magnets, right? When you talk about magnets, what type of things can be attracted, right? What type of thing that can be attracted? Nails, iron nails is one example. These are simple question where they can ask, but people, children actually don't know these kind of answers, right? Steel, nickel is the type of a metal, right? And what else? Yeah, these three. Okay, so these three are some examples where you can give for objects which can be attracted through magnets, right? So what are the objects which cannot be do you have any doubt?
Teacher, keys also can be attracted by the magnet, no?
Key is iron, right? So if you want, you can tell it iron. Okay. Anyways, that's correct. Okay. So the object which is not attracted, something like plastic. Can you tell me more examples? Plastic. What else?
Wood.
Wood. Very good. Regiform.
Glasses.
Very good. So these are some type of things that you can tell for the example which cannot be attracted by the by the magnets. Okay, so clear. That is a short idea, the background story about magnets. You have two types of magnet. Magnets have magnetism as their property, and then you have some items, some objects will be attracted by the magnet, some cannot be attracted by the magnet. So you have some basic classification. Understood the idea? Clear? Anyone has a doubt? Anyone has a doubt?
No, miss. We can understand.
Okay. So now, I think you all don't have the tute, right? So let me send it to the... I'll share it through the screen. Okay? You look and write it. So the theory class student, did you receive the tute? I think most of the people's tute I posted today. I don't remember. Wait, I'll check. People's tute. Right. Start doing the first few question. Write the first answer. Do the first question. Let me tell you the questions. We will go slowly, step by step through this lesson, because at a point, if you are misguided, you will fall into trouble. Oh, wait. Write the first question. and add on this question as well. So there's a question missing over here. Do this question as well. Yeah, you will be receiving it. It will take some time, right? Since most of the people, like whoever I posted, people live far away. So therefore it will take some time. Probably like within next week, you will be, before the next class, probably you will be receiving the tute. Safia's tute I posted today. Nahla's tute I posted last time when I told you that I posted. So at that time I posted your tute. Write the answers, think on your own and do it, children. Once you are done writing, let me know. Everyone has to do, take out a book, take out a paper, write your answers for now until you receive the tute. For the theory class student, the other people, the external students, you can take out a book and then you can write it. So once the class is over, if you want the tute, you can leave a message to my WhatsApp number, then I'll share it to you. So this is my number. If you want, send. Let me know. Leave a message to this number. I'll send you the tute once the class is over. Not now. Right. So we'll discuss what are the two types of magnet. You have the electromagnet, right? So what is mean by that electromagnet? The magnet which shows the property of magnetism when current is passing through it. That you call it as electromagnet. Then you have the permanent magnet. Permanent magnet. So what is meant by permanent magnet? The magnetism characteristics of the material.
Is you're in Colombo?
Yeah.
So if I want the tube, I can purchase, right?
Yeah, you can.
Can I know how much is the tube?
So basically it's for the theory class students. I give it like I send it at once, 2 months, 2 months once I used to send it. So I have the tune for what? Electromagnetism, electronics, and hydrocarbons and their derivatives. So that is the lessons that we will be covering in 2 months, which is for September and October. And it does not change throughout. Okay, so this is what you have to tell. So even if the electricity is not supplied, the magnetism will be working. Right. So now are you all done, right? And then the objects. So objects like which I have written on the board, just a basic idea, but actually some children do not write it. Okay, sometimes they might forget it, so that's why I told you at the question. Right. So now we'll consider the next one. Right? We'll talk about the remaining. Right. Now we are going to talk about what is mean by magnetic field. Right? What is mean by magnetic field? Now you have a magnet. Let me take a bar magnet. Right? You have the two poles, north, south. Right? You have the two poles. Isn't that straight? Let me draw it straight. Right? So now you have a bar magnet, right? So now you know if a magnet is going to attract an object, the magnetism should be around the magnet. Okay, there is a specific area, the area around the magnet where the magnetism is spread, you call it as the magnetic field. Right? Now you keep a magnet here and I keep an object here. Will that be attracted? No. But when you keep it here, yes, it will be attracted. So that means what? Around the magnet, a small area where the magnetism is spread in order to attract an object. That you call it as the magnetic field. That you call it as what? Magnetic field. What is meant by magnetic field, children? You have a magnet, right? So area around the magnet where the magnetism is spread to attract an object, you call that as the magnetic field. Understood? Let me tell it once again. You have a magnet, the area around it, the area around the magnet where the magnetism is spread. Magnetism is the force that consisted in the magnet. Okay, magnetism is the ability to attract towards the magnet, right? So the area where around the magnet where magnetism is spread, you call it as the magnetic field. Understood? Understood, children?
Yes,
Clear?
miss.
Any doubts? Right. So then let's move to the next one, right? So now when you take the magnet, right? The magnetic field, right? So magnetic field is a vector. What is a vector, children? You have quantities can be in two types as vector quantity and scalar quantity. I hope you are aware of it, right? So always remember, since it is a vector quantity, since magnet is a vector quantity. What is a vector quantity? Has a magnitude and has a direction. The quantity which has a magnitude and has a direction, a definite direction, you call that quantity as vector quantity. What is meant by scalar quantity? Scalar quantity means which has a magnitude but does not have a direction, a definite direction. The direction can change throughout the time. That type of quantity you call it as the scalar quantity, right? Now remember, magnetic field is a vector quantity, right? What is that? Magnetic field is a vector quantity. That means magnetic field has a specific direction, right? The magnetic field will flow with a specific direction. That means The direction is from north to south. From north to south, right? From what's the direction? North to south. Not from south to north, no, right? Always the magnetic field will act from north pole to the south pole. You have two poles in magnet. It will be acting from the north pole to the south pole. Understood? Understood?
Yes, Miss.
Once again, let me tell it once again, right? What is mean by magnetic field? Magnetic field means you have a magnet, area around that where the magnetism is spread, you call it as the magnetic field. Then what did I tell? Magnetic field has a definite direction. Therefore, it is a vector quantity. And the direction which the magnetic field travels is from north pole to south pole. Is from north pole to south pole. Then what if you have a U magnet? What is a U magnet? The magnet which is in the shape of U, right? So you have a U magnet. So you have the poles marked. This is the north and this is the south. So from here to here, here to here. This is how the magnetism, not the magnetism, the magnetic field will travel. Understood? Got the idea? Got the idea, children?
Miss, can you repeat it?
Yeah. Look here. Which you want me to repeat it? From the beginning, from this part or this U magnet part?
No, Miss, the U magnet.
Okay. So now you have the U magnet, right? So now if you have a bar magnet, you can see in the north and the south. From north to south, I have drawn the arrow. From that indication, from that direction only the magnetic field will travel. Right? Now when you have a U magnet, this is how the U magnet will look like, right? This is a U magnet, right? So this is the north pole, right? Let me mark it here. This is the north and this is the south, right? So how will the magnetic field travels? From north to south. Then if you have a gap between north and south, right? So therefore this is the direction, right? Here to here, here to here, right? That is how the magnetic field will flow. Got it?
Yes, Miss.
Right. So then, what are we going to learn next? Right. So this is the basic idea that you have to know. Now we are going to talk about, now when you take this lesson, to make it little simple and track where we are, there are three main concepts. There are, how many three main concepts are there? There are three main concepts that you have to study here, right? Three main concepts where you have to study, right? So let me erase it and give you an idea. So therefore you can track yourself where you are. Give me a minute. That's it. Right? 1 second. Okay. Look here. So this is how the plan works. This is how we are going to learn. Right? Now that was the basic idea. Whatever I told you was the basic idea. Right? Under this lesson, you are going to learn three main concepts. You have how many main concepts? Three main concepts. So based on these three main concepts only, you are going to build this idea of the lesson. Right? So what are those three? Let me tell you what are those three. The first one, we will be talking about the magnetic effect of current, right? Magnetic effect of current. That is what we are going to learn for the first thing, right? Then we will be talking about the magnetic force. We will be talking about magnetic force. Then we will be talking about the electromagnetic induction. We will be talking about electromagnetic induction. So this is the plan that we are going to follow for the upcoming sessions. This is what we are going to do for upcoming sessions, right? So now today we will be talking about the magnetic effect of current, right? So the magnetic effect of current was introduced by Hans Christian Ørsted, right? He is the scientist who came up with the magnetic effect of current, and today we are going to talk about that, right? So I'm not doing everything at once because definitely you will be confused at the end of the class. So let me go step by step. So we will be completing a small portions at once. We will be talking all together, right? So today we are going to focus on this, and in the upcoming class we will be talking about all the remaining topics, right? Now let's talk about the magnetic effect of current. That is how the plan works. We are going to talk about magnetic effect of current, magnetic force, and electromagnetic induction. Now, magnetic effect of current. Effect of current. Right. So now let's get into this topic. Right. Now what we did so far was the basic. Right. Now we are going to slowly get into the real topic. Okay. So now this was introduced. This was introduced by a scientist called Hans Christian Ørsted. Hans Christian Ørsted. So he is the scientist who came up with the idea of magnetic effect of current. What did he tell? You have to know what did he tell. So if he is proposing to a idea, you would have to know what he is telling, right? Now he told when there is a current carrying conductor, right? When there is a current carrying conductor. Now you know what is a conductor, right? What is a conductor? The material which flows the current, you call it as conductor. So the current carrying conductor, you have a current carrying conductor, right? So when there is a current carrying conductor, it will create a magnetic field, right? What did he state? That if there is a current carrying conductor, it will create, right? It will create a magnetic field. Now they are connecting the current to the magnet, something related to this. There is a relationship between the current and the magnet. So we are going to talk about that, right? What is that? When there is a current carrying conductor, it will create a magnetic field at the vicinity of the conductor. What is meant by vicinity? The borderline. Something to make it simple term. Vicinity means the border, the surrounding, the closed area of the conductor. It will create a magnetic field. That is what he told. Vicinity. Right? What did he tell? If you have a current carrying conductor, it will create a magnetic field around the vicinity of the conductor. Right? That is what he proposed. What is vicinity? Vicinity is the surrounding, the close area to the conductor. At that close area, it will create a magnetic field. Understood? Got the idea,
Yes,
children?
miss.
So let me tell it once again. We are talking about the magnetic effect of current. What if magnet is affecting the current? Right? That is the topic that we are talking about. Right? So that topic was introduced by Hans Christian Ørsted. So the law which we stated, the law which I told was introduced by him. What is the law? If there is a current carrying conductor, it will create a magnetic field around the vicinity of the conductor. That is the law. You call it as the Hans Christian Ørsted law, right? Hans Christian Ørsted law. So that is the law. Understood? Got the idea about that? Clear?
Yes, miss.
Right. Now let's quickly write that down and come. If not, you will forget about it. Right? me a minute. Let me share the screen.
Miss,
Yeah.
Miss,
Yes.
will I be able to get the recording, Miss?
Recording. Yeah. Will be sent to the group.
Because due to my connection problems, I'm not audible properly.
Yeah, that's okay. You can
So I
watch the
can watch
record.
the recording, right?
Yeah, sure. You can watch it. So maybe
Okay.
after the class is over, we
Okay,
will be
Miss.
uploading the recording. Then you can watch it.
Thank you, Miss. Jazakallah.
You're welcome. Barakallah. Okay. So do these questions, you know. Hopefully you are doing it by yourself. Don't refer to the book or nothing. Just do it by yourself. Right? Simple ones. That is why I'm going step by step in order to you to write the answers by your own. Right? Do it. Write it down. Once you are done, let me know. If you have any doubts at the meantime, you can ask me. And Shura, I just wanted to tell you that today only we decided about that physics seminar where most of the children were requesting me. Like we will be covering up all the physics lesson of grade 10 with 5 weeks. Right? Each week we will be talking about each unit. Like imagine the first week we will be starting from 25th. Right? From 25th we will be starting. So on 25th, which is the first week, we will be starting motion in a straight line. So I will be teaching you the important points and we will be discussing the past paper question relevant to that. Right? So similarly, we will be taking 5 weeks to complete the entire physics lessons of grade 10. Right? So that is a paid session, right? Which we are currently doing for the chemistry, something like that. So once that is done, we will be doing for that. So we will be sharing the posters as well if possible. Share with your friends and tell them about this so then they also can learn, because most of the children suffer with the physics part where they literally don't know how to tackle the questions. So therefore I will be guiding you throughout. I will be teaching first of all what are the necessary things, then we will be discussing the question. At once I never go to discuss the question because you have to have the specific knowledge, right, to do the question. So half of the class we will be talking about the lesson and the latter part of the class we will be doing the question, right? So that will be commencing from 25th of September, right? So it is free for the internal students. So whoever the theory class students or the past paper class students, that is totally free. The external student has to pay an amount and join. So share with your friends so then they will also be benefited because the O levels are getting near. So hopefully this is a perfect time to study, right? Okay, so the questions are small. I think the time is enough, right? Let's move to the question. Let's discuss, right? Okay. So what is known as a magnetic field? The area around the magnet where magnetism is spreaded is known as magnetic field, right? So how magnet affects the current flow, right? So literally they are asking the law. What is the law that I stated? if there is a current carrying conductor, if there is a current carrying conductor, it creates a magnetic field around the vicinity of the magnet. Right? That is the law that you have to tell. Right? So then the next one. So who introduced it? Hans Christian Ørsted. Hans Christian Ørsted. Right? Understood?
Yes, miss.
Right. So we'll move to the next part. Right? We'll move to the next part. Okay. Right. So now we are going to talk about how this happens. What did he stated and how it happens. How, like, if you are observing what are the rules that we have to follow to identify the direction and everything, we are going to talk. Right? So now, children, there is a rule. Okay, from this lesson we are going to study certain rules. Right? So the rules are, give me a minute. Okay. Right. So the first rule, we are going to talk about the Maxwell corkscrew rule. Maxwell corkscrew rule. This is the first rule we are going to talk for today. Right? This is the first rule that we are going to talk for today. Why are we doing this rule? Why are we considering this rule? To identify the direction of magnetic field. Right? Why are we doing this rule? In order to identify the direction of the magnetic field when the current is passing. You know, right? Now there is a definite direction for magnetic field. It is a vector quantity and there is a direction. Right? So therefore we are going to consider that. Right? Now, what did he tell? The Maxwell's corkscrew rule is, okay, when there is a corkscrew, right? Corkscrew in a sense, you know, screw nail, where you will have a nail and there is a spiral line, right? As I have added in the picture. Give me a minute, Safia. I'll check your answers once I discuss this part. Okay? I'll check your answers. Wait. Right? So now can you see I have attached a corkscrew here. Look here. This picture. Right? So this is a corkscrew. Let me draw just a nail. Right? Let me draw just a nail. But imagine that's a corkscrew. Right? So there is a corkscrew. Right? There is a corkscrew. Right? So when the current, right? When the current is sent from up to down. Okay, that means when the current is sent downward, this is the current, right? When the current is sent downward, the magnetic field will rotate clockwise, right? I hope you know what is clockwise and anti-clockwise, right? So when the current is sent downwards, the magnetic field will rotate clockwise, right? The magnetic field will rotate clockwise. Right? So if, I think it's not straight, which I have drawn. Okay. Right? So the next one, the next idea. Look here. Now what if the current is sent upward? Right? You're supplying the current upward. Then it will rotate anti-clockwise. It will rotate anti-clockwise. That you call it as, that is the Max corkscrew rule. right? If the current is sent downward, right? If the current is sent downward, it will rotate. The magnetic field will rotate clockwise, and if the current is sent upward, the magnetic field will rotate anti-clockwise, right? That is the rule, right? That is the rule that you have to know, anti-clockwise. Okay, so once again, let me repeat it. There is a corkscrew, right, which will rotate, which will move in the direction of the magnetic field. When the current is sent downward, the magnetic field will rotate clockwise, right? It will start to spin in this direction, right? Now imagine this is the corkscrew, right? So the current is sent downward. I am sending the current from here to here, downward, okay? Then it will start to rotate in this direction. It will start to rotate in this direction. This direction is the clockwise direction, right? Now I am sending the current upward, right? I am sending the current upward. Then the magnetic field will rotate anti-clockwise in this direction. Understood? That you call it as the Maxwell corkscrew rule. When the current is sent downward, the magnetic field will rotate clockwise, and if the current is sent upward, the magnetic field will rotate in anti-clockwise. Understood?
Yes, miss.
Right. So that is the first rule that you have to know. Write that down before we move to the next one. If not, you will confuse yourself. I don't want that to happen. So write that. So here should be two rules. This is the first one, the corkscrew rule. First write about the corkscrew rule, which I told you. Write that and leave some space to write the next one. Since you all don't have the tune, it's okay. Just write it. So once you got the tune, manage the space and write. No, that is A and B. Okay, the corkscrew rule is this. Okay, I have given space. I did not see this. Write in A whatever I told you. Look at the picture. If you want, you can draw, write. Make sure you're clear with what you learn. Right? Please don't forget the stuffs that you learn in the class. Safia, your answer is correct. Good. Your answers are correct. Right? Done writing? Yeah, in the upcoming classes, we will be continuing this. We are not going to complete the entire unit today. We will be talking about the certain points and certain ideas. And in the next class, we will be talking the remaining. Probably we will be having this lesson for 3 to 4. Maximum will be 4, not more than that. Minimum is going to be 3. At the same time, this is the class 10 for grade 11 theory. We will be doing at this time itself every week. No, the grade 10 past paper class is done. We have completed the grade 10 syllabus and now we are moving to we are in the grade 11 syllabus. We have started this week the grade 11 syllabus to do as a paper class. So that is why I thought of discussing like having a 1 month seminar for physics. Since we had the chemistry, most of the children were requesting for that. So that will be happening from 25th probably. Right. Shall we discuss? Are you all done, children? Shall we move to the next part?
Yes.
Okay. I hope everyone is writing this down. Okay, even though you don't have the tune, that's okay, children. You all have to do the work, right? So make sure you're utilizing the time instead of just looking at the screen. That is a pointless, right? So make sure you're sitting and doing the work. Whatever I tell you to write, please write them down because this lesson is important. Not as you think, you can't cover it in like sitting for just 2 hours, 3 hours, you can't complete this lesson, right? If you're learning for the first time, that is why I'm taking around 3 to 4 weeks. Imagine a teacher takes 3 to 4 weeks to complete a lesson. That much it is important. And apart from that is important where you should have a proper idea to attempt the question, right? So when you're little bit of misguided when in this lesson, you will totally collapse your idea. Everything will be messed. So that's why I'm going step by step. Once after it is a rule, I make you all right. That is the reason. If not, I can give at once. But I'm not doing that because you have to understand one by one. So that is the only purpose of doing this. Right. We'll write it. We'll write it over here. So what are you supposed to write? So there is a corkscrew, right? When the current, okay, let me write it. When the current is, first of all, you have to mention what is the rule, right? The rule is Max Bell's corkscrew rule, right? So the rule is when the current is sent downward, the magnetic field rotate clockwise. Okay, then next point, then when the current is sent upward, the magnetic field will rotate anti-clockwise, right? So this is what you have to write. Okay, so if you have written this, good job. If you haven't written this, write something similar to this. Okay, so now let's talk about the second rule. Okay, now we are going to talk about the second rule. Okay, we'll start. Okay, so the second rule is right hand grip rule. We are going to talk about right hand grip rule. Okay, we are going to talk about right hand grip rule, right? So what is that rule? Now you are going to use your right hand. Take your right hand. Okay, this is the right hand. Okay, now what are they saying is, let me take some instruments. Okay, you're taking your right hand. Since this is the right hand grip rule, you're going to place a conductor. This is a conductor. Imagine this marker is a conductor. You're going to place it, right? The thumb will indicate the current and the four fingers will indicate the magnetic field. Right? The four fingers will indicate the magnetic field. This is the right hand grip rule. Right? This is the right hand grip rule. What is that rule? The current, the conductor in the right hand should be placed, right? Then the thumb will indicate the current flow. Thumb will indicate the direction of the current flow. Then the four fingers will indicate the direction of the magnetic field. That is the right hand grip rule. Got it?
Yes, Miss.
Right. Okay, so this is what you have to understand. This is the right hand grip rule. Let me tell it once again. You are going to take a conductor, you are going to take the hand, right hand, you are going to place the conductor, then you fold your four fingers, then you can see the thumb to which direction it indicates, to this direction, right? Then you can see the magnetic field this way, right? So if you take it to other side, this is how it looks. Electric current, right? The current flow. Then the magnetic field. Then the current flow is upward. If the current flow is upward, what is going to be the magnetic field? What is going to be the magnetic field? Anti-clockwise, right? If it is the, look here, the current flow is this, my thumb, right? It is facing upward, right? Then the magnetic field around my hand to this direction. So what is that direction? It is the anti-clockwise. How do you check whether the anti-clockwise or clockwise? Draw a clock if you are not that sure. 3, 6, 9. So you keep here, right? Let me show. If I keep it here, you can't see, right? So you keep here. My thumbs are rotating towards this side, then this direction. So what is that direction? Does the clock rotate in this way? Does it move in this way? No. It usually 12 to 3, 6 and 9. This way, right? Then what you can tell, this is the anti-clockwise direction. Make sure you are able to find the direction, clockwise and anti-clockwise. Don't write it as clockwise for this. This is anti-clockwise. Understood?
Yes, Miss.
Okay. Then you should know the symbol. There is a dot and a cross, right? There is a dot and a cross. If you have a dot, okay, a dot inside a circle, right, is used to indicate the outcome of the magnetic field, right? To indicate the magnetic field, you have to use a dot, right, or a cross. Dot you use in order to show that it is coming outside, right? Coming out. Cross means going inside. Okay? Cross means going inside. Right? Now, you have the conductor, right? The current is this way. Right? Then you can see when the current is upward, the magnetic field is down. It is going down. Right? It is going down. Then, that is a dot. Sorry, not dot. That's a cross. It is going down, inside, then it is a cross. Then if I mark it in this way, right, I'm sending the current downwards. You can see my thumb, I'm placing downward, right? Then you can see the dot. It is coming out, right? From the conductor, it is coming out, the magnetic field. Understood? Now imagine you take a pen, right? Now in the exam hall, you can't carry a marker, right? You take a pen, right? Let me take a pen. Okay? Now, if you see this point, the moving point, I hope it is clear, right? This part, that is a cross. Imagine this part is going to be the cross. And the writing part, the point, right? The point, I hope it is clear, right? The point is going to be the dot. Now, when you keep this, you are sending the current upwards, right? Your thumb is facing upward. Then that means what? You are sending current upward, right? When you send current upwards, what is going to be the magnetic field? It is going inside or coming outside. You see this part, What is that?
Inside.
That means the magnetic field is acting inside, right? Then the other way around. My thumb, I'm sending the current downward. I'm sending the current downward. What do you see here? You keep a pen. What do you see? I hope it is visible, right? What do you see here? You see the point. Point in the sense I told you to remember the dot. Dot means it is coming out. It is coming out. Understood the right hand grid rule? Got it? Got it, children? Look here, I'll explain once again. Right? I'll explain once again. You should have a proper idea. The clean idea should be flowing in your brain. If not, you will fall into trouble. That's what I'm trying to repeat it once again and again. Right? Look here. Right? Look here. What is the first thing that you have to know? First of all, you have to indicate what is the current, what is the magnetic field. So that what I'm going to take, first of all, you have to take your right hand. You're going to take your what? Right hand. You're going to place a conductor. This is how he tells, right? You're going to take a conductor, right? The thumb is going to indicate the current flow. Is going to indicate the current flow. Then the four fingers will indicate the magnetic field. Will indicate the magnetic field. Then to tell the direction whether the magnetic field is going inside or coming outside, you to use this one. If you see the dot, if it is marked with a dot, that is mean coming outside. The magnetic field is coming outside. If you see a cross, that means it is going inside. Right? Now look here. Look here. Now this is the dot. This is the cross. Imagine this is the dot, the writing part. Okay. This is the dot. This is the cross. Okay. Right. Now I am going to indicate the current upward. The current is set upward. Right. I am placing the conductor. Right. Now what are you going to see? What are you going to see here? What are you seeing here? The up part. That means the cross. That means the current is going. The magnetic field is acting inside. The magnetic field is acting inside. You take the other way around. Right? The thumb, the current flow is downward. What do you see here? The dot. You see the dot. That means it is coming outside. That means it is coming outside. Understood the part? Understood the right hand grip rule?
Yes, miss.
Right. So this is what you have to know. These are the two rules where Hans Christian Ørsted told. Right? In order to find the direction of the magnetic field. Right? In order to find the direction of the magnetic field, you are going to use two rules. One is the Maxwell's corkscrew rule and the other one is right hand grip rule. Understood?
Yes, miss.
Right. Clear? Anyone has a doubt? Anyone has a doubt, ask me. Nahla, did you understand the second rule or you want me to explain once again? I just now read your message. Do you want me to explain once again? Okay. Right. All done. You're welcome. Right. So now, take out the tute and let's do the questions. So we are going step by step in order you to understand the process completely because you are not supposed to forget this throughout the lesson because we need it. We have to use this. So you are not going to forget it. Right? Write it down. Write it down. What are you going to write? What are you going to write? So whatever you learn. Not about the dot and cross. First of all, tell the thumb will indicate the electric current. The four fingers will indicate the magnetic field. So if you write something like that, it is correct. So thumb will direct the electric current, right? So the direction of other four fingers will indicate the magnetic field. That is what you have to tell. That is the right hand grip rule. Okay, I think the time is enough. Shall we move to the next part?
Okay, Miss.
Right. So is everybody is done? First of all, did you all write it, children? Or just wondering with this by looking at the screen? I don't want that to happen. I want you all to write. I want you all to work. If it is a dot, the current is not the current. The magnetic field is coming outside, right? If it is going if you see a cross, that means it is going inside. Yep, it's indicating the magnetic field. Right? So it is a way to identify the direction of the magnetic field. That is why we studied two rules, and that was the concept which is introduced by whom? Hans Christian Ørsted. So he is the person who introduced about the direction, and we came up with two rules, which is the Maxwell's corkscrew rule and the right hand grip rule. Right? So those are the two rules where we use to find the direction of magnetic field. Okay, so I think the time is enough. We'll move to the next part, right? So as I told you, if you have written that, that is correct. The thumb, if you want, I'll tell you again. The thumb of the right hand will indicate the electric current, the direction of the electric current. The other four fingers will indicate the direction of the magnetic field, right? That is what you have to know. Okay, right. Now we are going to talk about the next one, which is we are going to talk about the third rule. Okay, we are going to talk about the magnetic force. At which direction does the force exerted? We are going to talk about that. Okay, right. So for that, we are going to use a rule. Now, as I told you, today throughout the day, you are going to study about rules, right? So today, now we are going to study the third rule, which is the Fleming's left hand rule. Fleming's left hand rule. Okay, we are going to talk about Fleming's left hand rule. Right? Now, what is he saying? Now, you're going to take your three fingers of your left hand. You're going to take your three fingers of your left hand and the thumb. The thumb is going to indicate the force. The thumb is going to indicate the force. I hope it is clear. Give me a minute. Let me check. Right? You have three fingers of your left hand. You're going to use your left hand. Don't use your right hand. That is going to be a wrong experiment. Okay. So the thumb is going to be indicated by the force. The thumb you are going to use to indicate the force. Right. You have three things that you have to use to indicate. Right. So then the finger, the index finger, to indicate the magnetic field. Right, to indicate the magnetic field. Then the third finger, right, the third finger you use to indicate the current. The middle finger you use to indicate the current, right? Force, magnetic field, current, right? Force, magnetic field, current, right? Now, what did he state? What did they state about this Fleming's left hand rule? All three are perpendicular. Now you can see these two. Perpendicular. You take these two. Perpendicular. So what can you tell throughout this? All three, force, magnetic field and the current flow is perpendicular. Understood? Understood the idea?
Yes, miss.
Yes.
Right. Then what did they tell? The current, not the current, the force depend on the magnetic field and the current flow. Force depend on the magnetic field and the current flow. Magnetic field you indicate it by the letter B, capital B. Right? I'll draw it on the board. First of all, understand with my hand. Then we can use the book. Right? So let me tell it once again from the beginning. Right? From the beginning, let me tell it. You are going to use the left hand for this. Fleming's left hand rule. Right? He is going to take the three fingers. The thumb is going to indicate the force. The thumb is going to indicate the force. Right? Then this index finger, this finger you call it as the index finger. This finger will indicate the magnetic field. This finger will indicate the magnetic field. And the middle finger will indicate the current. The middle finger will indicate the current. Something like this. Okay, they are perpendicular. They are perpendicular. Right? They are perpendicular. Okay, that means force depends on the magnetic field and the current flow. Force depend on magnetic field and the current flow. If any of these factor increases, what will happen to the force? It will also increase. If the magnetic force is high, the force will increase. If the current is high, the force will increase. That is the idea. And what you have to remember, all three are perpendicular. All three are perpendicular towards each to other. Right? Understood the process? What is I'm talking about? Did you get an idea of what is happening?
Yes, miss.
Right. Now, what are we going to talk about is we are going to talk about an experiment to find the current flow. Right? To find the current flow. Right? Now, when you have this sort of a setup, first of all, let's write the rule and then I'll explain you the process. Write this below first of all, then we can move to the work. If not, it will be confusing. And children, before coming to the next class, make sure you revise all the rules and come. Okay? So make sure you're not forgetting any of the part. Can you write for C, the rule which I told you? The thumb will indicate the force. The middle finger will indicate the current. The index finger will indicate the magnetic field. You have to tell they are perpendicular to each other. Then if one factor, if force is equal to magnetic field and electric current, if any of these two factor increases, the force will increase. You have to tell that as well. Yeah, you have to memorize the rule. Apart from memorizing, you have to understand how that rule works. Right? If they ask you the right hand grip rule, you have to know to indicate by your hand. You have to use your hand for this. Right? Without using the hand, you can't do questions. Huh? So while we are discussing questions, I will be telling you how to apply these rules in the question. Right? You have to know to apply. You have to use your hand. It's not about memorizing, it is about understanding. They don't ask you to describe, but you should be able to use the rule in the given question. That is important. So anyways, if you memorize, that is fine, no problem. Right? Done? Yeah, the force will depend on the magnetic field and the current, right? When you take the Fleming's left hand rule, this force is there, right? Force is dependent on the magnetic field and the current flow, right? That is what you have to understand. If one factor increases of 2, that means the force will be increased. Do the work, children. I want you all to do. Okay? Don't just wait. This lesson is not that hard, but a proper understanding is needed. If you are not understanding it properly, that is where the problem comes. So that is why I am going step by step, like I'm literally spoon feeding to you all. Not going at once, just giving you the explanation, making you all to write. So that is where you will learn. Because I just don't want to mess up everything at once. Done? Shall we move to the next part? Right. I think the time is enough. So let's discuss. So what are you supposed to write here, children? First of all, you have to tell. Okay. The thumb will indicate the force, direction of the force. All you have to mention is the direction, the term direction, right? So the index finger will indicate the magnetic field. Then the middle finger will indicate the electric current flow, right? Then what do you have to tell? If one force is equal to magnetic field and electric current, if one factor of these two increases, the force will also increase. And you have to tell all three are perpendicular to each other. So if you have written that, if you have done with that, you are done, right? So we'll move to the next part. Right. So then now we are going to talk about an activity under this. We are going to talk about an activity under this. Okay. Right. Shall we do it today or we'll do it? So it's better if I explain with the picture which I have given in the tutor. Right. Look here, look. I'll explain with that instead of drawing and wasting the time. Okay. Now we are going to discuss this experiment, right? This experiment is done to check the force acting on the current carrying conductor with a magnetic field, right? Now here you see the green color one, which is a bar magnet. Okay, the green color one which you see is a bar magnet. Sorry, not a bar magnet, it's a U magnet. I'm sorry. So you have placed the U magnet, right? So U magnet will be in the shape of a U, right? So there is a space in between the North Pole and the South Pole, right? So in between the space, you are going to have two brass rod. You are going to have two brass rod, which is in blue color. You can see there is a two brass rod where you have to connect the magnet, the U magnet and the brass rod. Okay. Then what do you see? Then you have to take a cardboard, a thick cardboard, and you have to pierce a hole and you have to connect it to the dry cells. Here you have seen the dry cells and here is a switch. You have to connect it. The one side you have to connect it to your switch and the other side you have to connect it to a dry cell. Right? Then you form a circuit. Something like circuit you form. right? So when you close the switch, when this switch is closed, you know, in order to flow the current, the switch should be closed, right? So when you close the switch, and there should be a conductor, okay, there should be a material which can pass the current, okay, which you call it as a conductor. BC is a conductor, right? You have placed it on the brass rod, okay. So when you placed it between the north and the south of the magnet, what is going to happen? Okay, so allow the current flow by closing the switch. Now we are going to allow the current flow by closing the switch. Then what is going to happen? The current flow from the cell, okay, the current flow from the cell through the brass rod along the direction AB. Now you see the dry cell, okay. Since you close the switch, the current is going to flow, right? The current will flow from A to B. Current is flowing from A to B through the conductor, then B to C, okay, from A to B and B to C. Then what is going to happen? Then it reaches from C to D, okay. That is how the current is flowing, right, at this direction, okay. Current is flowing in this direction. It is starting from here, moving from A to B, B to C, C to D, right? That is one thing that you have to understand. Now this is a preparation that I am saying to undergo the process, right? This is what you have to arrange the setup. This is sometimes they can ask you questions like this, right? Okay. Then what can you tell? When the current, now you can observe that the conductor BC moves along the brass rod away from the magnet, right? Now what is going to happen? The conductor BC is there, right? It will start to move away from the, okay, moves along the brass rod away from the magnet. That means it is going to come towards here, right, away from the magnet. You can see that when the current is flowing in this manner, okay, when the current is flowing in this manner, the conductor will move away from the magnet and it will be going closer to the brass rod. Understood the point? Understood? When you supply the current at this direction, right, when you supply the current at this direction, the the conductor will move away from the magnet itself. Okay, they are telling that the conductor will move away from the magnet. That means to the right hand side. Okay, that is moving to the right hand side, this side. Okay, which will move to this side. Right. Then what do you do?
Teacher,
You
can you
change.
explain it again?
Yeah, first of all, listen, I'll tell once. Then I'll start from beginning. Right. Still I didn't finish the point. Okay. Wait a minute. I'll first explain the entire process. Then I'll explain it once again. Right. Now what is going to happen? You're going to change the terminal. You're going to change the terminal. Right. So when you change the terminal, the current flow will change. Okay. The current flow will change. So the current, now what is going to happen? It is going to move from C to B. The conductor B to C is there, right? Then it will move backwards, closer to the magnet. Right? It will move closer to the magnet. Now listen, I'll tell from the beginning, right? First of all, I told you the arrangement. Right? Let me erase everything. Look here. Right. Now you have a conductor. You see you have a conductor. You have a U magnet. Right. There is a cardboard and you have arranged the circuit. You have a dry cells. You have some dry cells and a switch. When you close the switch, this dry cell will start to produce current and it will flow through. Right. So how is the current is going to flow from A to B, B to C, C to D. That means in this direction. This is how the current is going to flow. When the current is flowing in this direction, what are they saying? The conductor, which is the BC is there, that is a conductor. It will move away from the U magnet. Understood?
Yes,
Understood?
teacher.
This is the first one that I told, right? So when the arrangement is in this setup, from A to B, B to C, C to D. The current is flowing in this direction. The conductor will move away from the magnet. That is the first point that you have to know. Then let me take another color and explain the other part. Right? So look here. So then what are you going to do? You are going to change the direction. You are going to change the terminal. First of all, you are going to change the terminal of the dry cell. So when you change the terminal of the dry cell, it will move the other way around. It will move, the current flow will happen other way around, right? So it will start moving at this and at this, right? This is the other way around. Okay, so the other way around, it will start to move the current. The current will flow in the other way around. So when the terminal is changed, the conductor will move towards the magnet. Okay, when the terminal is changed, the conductor will move towards the magnet. Right? That is the 2 points that I took. That means it will move to the left hand side. Before it was moving to the right hand side, where it came closer to the brass rod, because it was moving away from the magnet. That means to this side, which is the right hand side. Now it is moving to the left hand side. Right? Then what can you tell about this? The conductor placed in the magnetic field move when the current flow. Okay, through the conductor. So the force can be changed, acting on the force. Right? So a conductor which is placed in the magnetic field. Okay, you have placed the conductor in between a magnetic field, right? So when you have done that, the current flow through the conductor as a result of the force acting on it. Okay, so when the force is acting closer, the current flow is different. When the force is acting away, then the current flow is different. So that is the idea that they are telling us. That is the idea that they are telling us. So the force depends on the current flow, right? So when you change the direction of the current, the force is different. Why? Then all you can see now. Initially, imagine this is the conductor. This is the U magnet and this is the conductor, right? So when the current flow is at this direction, right? When the current flow is at this direction, the conductor will move away. The conductor will move away, right? When it is in the opposite direction, then the conductor will come closer. Then what you can understand? When the direction of the current flow changes, the force will be changed. The force acting on it can change, right? It can result the change of force. So that is what they are telling you. That means the force depends on what? Magnetic field and the current flow. Magnetic field and the current flow. B is the magnetic field, I is the current flow. So that means force depends on magnetic field and current flow. Understood?
Yes, miss.
Right? So let me tell it once again. I'll use the markers. So this black color marker is going to be the U magnet where we using the setup, right? So this is going to be the conductor. The blue marker is the conductor, and I'm going to, if this is the one point and this is the other side, right, of the terminal of the battery. So when it is kept in this side, okay, look at this. When it is kept in this direction, then the conductor will move away from the magnet, right? This will move away from the magnet. Now what I'm going to do? I'm going to change the terminal, the direction of the current flow. Then then the conductor will go closer to the magnet. Right? Therefore, what can you state? Force depends on magnetic field and current. Understood?
Yes.
Clear? Any doubt?
No.
Right. Now, write it down. Write it down, whatever I told. So you have to tell what I supposed to tell. Relevant to this stated, when the current flow, if not, I'll give you the answer. Write this what I'm writing. Okay, give me a minute. Write this down, children. So then children, remember the force. Okay, the force acting on the conductor depends on three factors, right? Let me tell you those three. Look for a minute. Look at the board for a minute. Have I off the video? Okay. Look at for a minute, children. Stop the work and listen. Right? So the force depends on three factors. Okay, the force depends on three factors. The first one is the magnitude of the current. Magnitude of the current through the conductor. Okay, flowing through the conductor. That means if the magnitude is less, right? If there is a small amount of current that is flowing, then the force is less. That is what overall you have to understand, right? If the current magnitude of the current is higher, then the force is higher. High force is needed, right? If the magnitude of the current is lower, a little amount of force is enough. That is one factor, right? Then the next one, the length of the conductor. Okay, the length of the conductor between the rods. The length of the conductor between the rods, right? Then for the third one is the strength of the magnetic field. Right? So these are the factors depending on force. That means if any one of these reduces, decreases, then the force will decrease. Right? So if any one of these increases, the force will increase. That is the idea that you have to get. Write down this for the next question as well. The below given one. So no worries. Anyways, in the past paper class, we will be talking about how this all the rules and how to exert everything, and we will be studying in the past paper class while we are doing the past papers. So anyways, the next part, the next week we will be talking about how if this is happening, to find the direction. We will be doing that in the next class, right? So that revise the lesson and come, right? Revise whatever the rules that you studied and come. We will be talking about that. Right then, children?
Teach.
Sorry. Do you have any doubt? Do you have any doubt, Safia?
No, teacher. Finish writing.
Okay. I'll just write this down. Make sure that you don't forget anything. Make sure you are having a clear idea of the lesson, right? Yeah, next week we will be continuing this lesson. So that's why today's class I just gave a basic idea whatever you need for the upcoming classes. So if you are having any difficulties of this part, make sure you revise it thoroughly and come. Right? If you have any doubt, you can ask me, right? Or else revise it once again and come. For the past paper class, we will be probably doing this lesson next month. Yeah, we are doing with the chemistry, right? So now once that is done, so by the next month, first week, we will be completing the chemistry, right? Then throughout the weeks, we will be having physics to do because most of the lessons are physics. We'll see, inshallah. Then writing. This is the answer for the 8th question, right? Hopefully you write it. Done, children? Is everybody's done? Hafsa, Nahla, and Sahla, Zainab, are you all done?
Yes, miss.
Okay, how about the others?
Yes, miss.
Hafsa, Nahla, and who else? Yes, so everybody's done, right? So then that's all for the day. Okay, hopefully, did you all understand? First of all, tell me that. Did you all understand the lesson?
Yes, miss.
Yeah.
Yes,
So
miss.
then,
Yes,
inshallah,
teacher.
down. Okay.
I missed the 6th question.
Sorry.
Missed the 6th question. Can you repeat?
6th one. 6th one we will do it in the next class. First of all, we have to study for that. We'll do it in the next class.
Okay, miss.
Right. So did you all have idea of the lesson, how it's going to work, and the rules that we studied today?
Yes, teacher.
Right.
Yes.
So then that's all for the day. Okay. Hopefully that you revise the lesson and come on the next class. Okay. This lesson is important, and apart from that is important, this is a complicated one. I don't want to lie. This is little indirect way they ask questions. So while we are doing the past papers, you will understand that. Okay. So make sure you study properly and come to the next class, and we will be continuing this lesson. Right. So if you have any doubt after class, you can ask me like in the WhatsApp, or you can ask me if you have any doubt right now as well. Right. So that's all for the day. Thank you so much. Assalamu alaikum. Take care. Bye. We'll meet on the next class. Inshallah.
Walaikum